Imagine staring into the vast expanse of the universe, a cosmos brimming with mysteries far beyond our reach, until now. With the advent of the James Webb Space Telescope, JWST, we have an unprecedented tool that allows us to peer deeper into the cosmos than ever before. Since its launch in the summer of 2022, JWST has been making waves in the scientific community, unlocking cosmic secrets that were once thought to be beyond our grasp. As the world's most powerful space telescope, it's rapidly becoming a cornerstone of modern astronomy, and with every new discovery, our understanding of the universe is evolving at an extraordinary pace. The James Webb Space Telescope isn't just any telescope. It is the successor to the Hubble Space Telescope, but with capabilities that go far beyond Hubble's reach. JWST is a marvel of engineering, equipped with a golden, hexagonal mirror that spans 21.3 feet in diameter, and a suite of instruments designed to observe the cosmos in infrared light. This advanced technology allows it to capture faint signals from some of the most distant objects in the universe. Unlike visible light telescopes, which are limited by the amount of light they can capture from faraway objects, the JWST can detect infrared radiation, which is crucial for studying distant galaxies, stars, and cosmic phenomena. Among the most exciting discoveries made by JWST so far are quasars, some of the most energetic, enigmatic, and distant objects in the universe. Quasars are extremely bright and powerful centers of galaxies, powered by supermassive black holes at their cores. As matter from surrounding gas and dust is drawn into these black holes, it accelerates, heats up, and emits massive amounts of radiation, making quasars the most luminous objects known in the universe. In fact, a single quasar can emit more light than the combined total of all the stars in its host galaxy. However, despite their brilliance, quasars have been incredibly difficult to detect. Their immense distances from Earth, combined with their tiny size relative to the galaxies they inhabit, have made them elusive targets for astronomers, until now. Thanks to JWST's exceptional infrared sensitivity, these faraway quasars are now visible to us, offering a window into a time long before the Earth and our solar system even existed. The telescope's ability to capture faint infrared signals from these objects has provided us with the ability to see quasars as they were billions of years ago, when the universe was still in its infancy. This is one of the most remarkable aspects of JWST's observations. When we look at these distant quasars, we're not just seeing them as they are today, we're seeing them as they were in the past, often billions of years ago. In a sense, the James Webb Space Telescope is a time machine, allowing us to look back into the deepest reaches of the cosmos and understand how it has evolved over time. One of the most exciting developments coming from JWST's study of quasars is the discovery of a trio of quasars that reside within a single galactic structure. This quasar triplet, located more than 12 billion light-years from Earth, is one of the most fascinating discoveries to date. Each of these quasars is powered by a supermassive black hole, and each one emits an incredible amount of radiation. But what makes these quasars especially intriguing is the fact that they exist within the same cosmic structure, offering researchers a unique opportunity to study the interaction between multiple supermassive black holes and their surrounding galaxies. The quasars in the triplet are located in different regions of the same galaxy, but they are so far apart that they are likely not influencing each other directly. However, their collective energy output is enormous, making the region one of the brightest and most powerful in the universe. For astronomers, the quasar triplet represents an incredible opportunity to study the processes that occur in the hearts of galaxies when supermassive black holes interact with their host galaxies. This discovery could help answer some of the most fundamental questions about the growth and evolution of black holes and galaxies, including how supermassive black holes form and how they shape their surrounding environments. The James Webb Space Telescope's ability to resolve such distant and faint objects has been a game-changer in our understanding of the early universe. By studying the light emitted by these quasars, astronomers can learn about the conditions of the universe just a few 100 million years after the Big Bang. This time period, known as the Epoch of Reionization, is one of the most important phases in the history of the universe. During this time, the universe transitioned from being opaque, filled with neutral hydrogen gas, to being transparent to light, as the gas became ionized by the radiation emitted from stars and quasars. The fact that these quasars were formed so soon after the Big Bang suggests that supermassive black holes were already in place at that early stage of the universe's evolution. This raises an intriguing question: how did these supermassive black holes form so quickly? One possibility is that they grew rapidly by accreting large amounts of gas and dust in the early universe. Another possibility is that they formed from the collapse of massive stars, although this would require a very specific set of conditions. By studying the light from these ancient quasars, astronomers hope to answer this question and gain a deeper understanding of how black holes grew to become the cosmic giants they are today. The James Webb Space Telescope is also providing insights into the environment surrounding quasars, which are often filled with gas, dust, and radiation. These surroundings play a critical role in shaping the behavior of quasars, including their energy output and their ability to influence the formation of stars within their host galaxies. The radiation emitted by quasars can heat up the surrounding gas, preventing it from collapsing to form new stars. This process, known as feedback, is believed to play a key role in regulating star formation within galaxies, and it could have a profound impact on the evolution of galaxies over cosmic time. One of the most fascinating aspects of studying quasars is understanding the relationship between the supermassive black holes at their centers and the galaxies that surround them. Supermassive black holes and galaxies are thought to evolve together, with the growth of the black hole influencing the growth of the galaxy and vice versa. This idea, known as coevolution, is supported by observations of quasars in the early universe. By studying these objects in detail, researchers hope to uncover more about how supermassive black holes and galaxies interact, and how this interaction has shaped the universe as we know it. In addition to studying quasars, the James Webb Space Telescope is also providing valuable insights into the broader universe. For example, JWST is helping astronomers investigate the process of galaxy formation and evolution. By observing distant galaxies, researchers can gain a better understanding of how galaxies have evolved over time and what conditions were necessary for them to form. The telescope's infrared capabilities allow it to peer through the cosmic dust and gas that often obscures our view of distant galaxies, providing a clearer picture of their structure and composition. One of the most exciting discoveries made by JWST in this regard is the detection of galaxies that formed just a few 100 million years after the Big Bang. These early galaxies were much smaller and less mature than the galaxies we see today, but they were still capable of forming stars and hosting active supermassive black holes at their centers. Studying these early galaxies will provide astronomers with crucial information about the conditions that existed in the universe's infancy, and how those conditions gave rise to the galaxies we see today. But the James Webb Space Telescope isn't just focused on studying quasars and galaxies. One of its other major missions is the search for exoplanets, planets that orbit stars outside our solar system. JWST is uniquely suited to this task, thanks to its ability to analyze the atmospheres of distant planets in unprecedented detail. By studying the light from these planets, scientists hope to learn more about their composition, climate, and potential for habitability. One of the most exciting exoplanet discoveries made by JWST so far is the detailed study of WASP-39b, a gas giant located about 700 light-years from Earth. By analyzing the planet's atmosphere, astronomers discovered a wealth of chemical elements, including carbon monoxide, sulfur dioxide, and water vapor. While WASP-39b is unlikely to be habitable, being a gas giant with extreme temperatures, this discovery is an important step forward in our understanding of exoplanet atmospheres. It demonstrates the incredible power of JWST's instruments and paves the way for even more detailed studies of potentially habitable planets in the future. In addition to studying individual exoplanets, JWST is also focused on understanding the broader processes involved in the formation of planetary systems. By observing distant star-forming regions, astronomers can study how planets are born, and how their environments evolve over time. This knowledge is critical not only for understanding the origins of our own solar system but also for identifying exoplanets that might harbor life. Another important aspect of JWST's mission is its ability to observe the earliest moments of the universe's evolution. The telescope's infrared capabilities allow it to look back in time, observing the universe as it was just a few 100 million years after the Big Bang. During this period, the universe was in a state of rapid change, with the first stars and galaxies forming and the first black holes beginning to grow. Studying this era of cosmic history will provide invaluable insights into the processes that shaped the universe and led to the formation of the structures we see today. As we continue to explore the universe with the James Webb Space Telescope, there is no doubt that many more exciting discoveries lie ahead. From the earliest quasars to the formation of planets and galaxies, JWST is helping us answer some of the most fundamental questions about the cosmos. With each new revelation, we are drawing closer to understanding the true nature of the universe, its origins, and its ultimate fate. The journey has only just begun, and the possibilities are limitless. Thanks to the incredible technology aboard the James Webb Space Telescope, we are now able to explore the farthest reaches of space and unlock the mysteries of the universe like never before.